the organizing committee that keeps doing their wonderful job for 7 years and many more to come. So, I'm Alexis Zavras. I'm doing open source compliance at a large American company called Intel.
This project.
Maybe. Okay. So our talk is about outsourcing our wonderful legal obligations, which is a nice, very nice, catchy title for the big companies. So at Intel, we deliver a lot of software. We are mainly a hardware company, as you probably know. That makes my job much easier because the company mentality is that software is just an enabler for us to sell more hardware. So it's pretty the default to make software open source. And we deliver a lot of software. And our software is always a combination of our own and open source software, right? And as is typical today, a typical software product is around 80% software that you get from other sources and 20% the software that you write yourself. If you're writing much more than that, you don't have a competitive advantage, something like that. So many software components that we use have a legal source code distribution requirement. I'm sure you've heard that before. And in our case, we also want to deliver sources for other pieces of software that may not have this obligation requirement, but we still want to deliver the source. Right. So this is a reminder for the legal requirement. This is copied from GPL v2, that when you deliver an executable, you have to deliver the complete corresponding source code. As it exactly says, complete source code, it means all the source code for all the module it contains, plus any associated interface definition files, plus the script used to control compilation and installation of the executable. And this is a basic idea in copyleft licenses, that you have to deliver the complete code of the software that you're delivering the executable for. Okay. The wording might change per license, right? Different terms may be used, but the idea is the same. So in GPL v2, it's called complete corresponding machine readable source code. And the verb that you have to fulfill is you have to accompany the executable with this thing. In GPL v3, the terms were changed to corresponding source, and you have to convey it. In Mozilla version 2, they're talking about source code form of the software, and you have to make it available. And this source code form has to be made available. It's a passive term, even. And in EPL v2, in Eclipse Public License, it's also source code, and it also has to be made available, right? So trying to fulfill these obligations, we were thinking of how to do this thing. In an ideal world, or in a very German organized company, I'm based in Germany, so you will have a foolproof process that it's in place and everyone follows it strictly, and you set it up once and everything works magically for the rest of your life. This is not always the case. It's not happening. In the practical consideration, especially if you're talking about a very large company spanning the whole globe, as we do, as we are. So people change roles, or they leave the company. Reorganizations happen, much more than you would think of. And things get forgotten, and people completely lose the corporate history of different products and stuff like that. So you have to make sure that you always deliver the complete corresponding source code, because the product, as you probably know, may have a very long life, much longer life than the original team that created the product. Right. So trying to build this in-house, we started thinking of what are the different use cases, right? So when we have to deliver source code, what do we have to deliver? And there are a couple of obvious use cases. So the first thing is we have to deliver the source code that we wrote ourselves. We have it a software package, tar archive, and we have to deliver this thing. A second use case is we have to deliver the very well-known package, like a GCC version, a specific version, how we build it, and all this stuff. Right? The third case, we have to deliver the same well-known package on a specific revision level, right? So not one of the published releases, but we took one specific one because it wasn't released as a release yet. We have a single commit. Anyway, we have a unique identifier for a specific version of an open source software which is out there. And the last bullet is a use case of a combination of this thing. So we took this well-known open source at a specific version, but we did some patches to that, and that's what we are using. And because we have to deliver the complete corresponding source code of the binary, we have to deliver this source code. So, and obviously there are combinations of that. Ideally, you can have a bundle because you might have more than one packages there, right? So these are the different use cases that we want to deliver source code from. So translating this into functional requirements, we need to provide our own software packages, right? The source code that we wrote and we have, right? Or we have to refer to well-known free and open source components that are on the internet with a release version or a specific commit or commit ID or something, a specific snap point, right? Snapshot. And we want to combine the two, right? Components with our own patches, with our own software, right? So the great idea that came to us is, can we outsource this fulfillment process, right? So instead of us doing it, can we ask somebody else to do it for us, right? The major legal question for this room is it compliant, right? Can we really outsource it without getting into trouble, right? And we had lots of discussions with John and all FSF and lots of other people and many of our lawyers. And so, for example, in GPL FAQ, there is this wonderful question, can I put the binaries in my internet server and put the source on a different internet site, right? So there are two GPL online, the GPL FAQs online for version 3 and version 2. Both of them, the reply is yes. So one is that you have to make sure that the source remains available, right? But you can have it somewhere else, right? And even in the older version for version 2, if you make arrangements to have it always there, we think that it qualifies from the same place, right? So it doesn't have to be on the same server. Let's ask if somebody else can do it, right? So thinking of all the trouble that we're getting into in order to fulfill this requirement, wouldn't it be great if we can find someone to fulfill this requirement? And we found Zach.
Thanks. Can you hear me? Yes, it works. So that someone here is not actually me, so I'm not going to host all the corresponding source code tables of Intel on my personal website. But the idea is to use the Software Heritage project as a place that can work with actors like Intel to host those complete and corresponding source code tables. So this talk is not about Software Heritage, so I will give you more pointers to learn more about the project at the end of the talk, or you can check out our keynote here at FOSDEM last year describing the project in detail. I will just go through the basics of the project that are relevant for the use case we're working on with Intel. So Software Heritage is a project whose mission is to archive the entire body of free and open source code software we can find on the internet. So we harvest forges, we harvest places where we know we can find source code, and we archive that. The mission, in a nutshell, is collecting all that body of source code, preserving it in the very long term to avoid it get lost, and sharing it with everyone who needs to access source code that we have archived. So we are focused on a single mission of doing the archival part. So but we are meant to serve different use cases. So there are some cultural heritage use cases. There are some industrial use cases, like the one we're discussing here today. There are some scientific use cases, like imagine offering researcher the ability to analyze all this code in a coherent way. And there are educational use cases. But the point is that we're only working on the foundation rather than try to implement ourselves the solutions for all the different use cases. And to maximize the chances of succeeding, given the mission is fairly big, we're developing it in a completely transparent and open way. So all the code we develop ourselves for the mission is free software, generally copyleft. And we're also setting up this as a non-profit endeavor because we think it has more chances to remain for a very long term if it is a non-profit endeavor rather than a for-profit one. By default, so before this kind of adaptation for interesting industrial use case, what we do is that we are a crawler. Okay, so we have a bunch of places we know are meant to distribute source code, like forges or source code packages in distributions or source code packages in language-specific package managers. And we crawl, so I won't go through the details of our architecture, but we're basically a crawler. We go in those places where we retrieve all the source code we can find, and we store it in a single data model where everything is deduplicated. So if we find the same file on multiple forges or multiple packages, we store it only once. Same thing for the commits, because we also store the entire development history of all the source code we can find. So this is our general architecture. And it's a real thing, so it's not just theory. So we already have assembled a very large and substantial archive of source code. So our sources that we track day by day are GitHub and Debian for now, and we have also ingested in the archive the entire history of Google code and Gitorius at the time they shut down. And we're working on ingesting also Bitbucket and adding other sources of source code. This is something like more than 4 billion unique source code files, about 1 billion commits coming from more than 70 million origins, so Git repos or packages or that kind of stuff. It's a pretty substantial archive if you see it as a graph, and we believe it's today the largest archive of public source code that you can find on the internet. And of course, it's growing daily because every day we recrawl those sources and find new stuff there to add to the archive. But this is the crawling part, the pull part. For satisfying the needs of distributors of products that contain source code, you need some sort of push way of adding stuff to the archive. So the idea here is that now we have a service that we are opening up as a prototype, which is a deposit service. So essentially, with people that are partners of the project, because we don't want to become, another mega upload or something where people go to just store warrants. But so if we have an agreement with Intel for working on this, for instance, they will have credential to access this service, and they can just, push when they want, when they add some software source code tarbles to the software heritage archive. In tech terms, it is an implementation of a protocol which is called SWORD, which is a protocol used by digital libraries to exchange articles or data set that has been deposited by a researcher on those services, but we have reused it for depositing source code. And it has a RESTful API that you can use to implement your own deposit tools with a command line wrapper that you can use as a ready-to-use tool. So as an example, imagine you have the software tarball that Alexios was talking about. Well, you create your tarball. That's not something we're going to do for you. That's not the part we're going to outsource for you. But you have your tarball. You have taken care of the fact that the tarball, it is indeed the complete and corresponding source code tarball for your project. And what you can do, you add some metadata that are not in the tarball itself. So you add, for instance, if you have an internal identifier for that release, you can put it in there. You can say the name of the project. You can say the person who is responsible. So a bunch of additional information about that tarball. And you have a tool in which you can use that to push it to the software heritage archive. So initially, it will give you an answer, which is essentially a receipt. Tell you, OK, we have received our tarball. And you have a deposit ID, which is number 11. And you can use that receipt to monitor the status of the deposit process in the software heritage archive. So why the status? Because we are not just going to keep your tarball. It's not an FTP service, okay? What we're going to do is that open up that tarball, look at everything that's inside, and integrate it in the rest of the archive. This way, when you go back finding your source code, you can see, for instance, where else it is being used and see it in context of all the rest of the source code we have in the archive. So using that receipt number, you can check what is the status, and at some point, well, ideally for small tarball, it will take just a few minutes, can be more for very large tarballs. At some point, it will tell you, done, this is done, and it will give you an ID, which is a persistent identifier of the kind of object that has been created. So this number here is the persistent identifier that we guarantee it will always work and will be around for reaccessing your stuff later. So with that identifier, you can reference stuff that has been in our archive. You have a URL where you can point your users, and you can navigate the thing in the archive. So for instance, even if I should never do demos, we are opening up the browsing interface to the archive for FOSDEM. So you can go to archive.softwareheritage.org. Password is 2018, and navigate the entire archive. And here, it's what you will see if you deposit a tarball, where you can navigate is a GitHub interface, and if it were something more, a more complex object, like a git dump, for instance, you can see the revision history and that kind of stuff. Also, you can, of course, download it, because that's the point. You want to point your users to our archive to retrieve the source code. So there is a service, which is called the Software Heritage Vault, when you can request to download stuff. That too is an asynchronous service, because we deduplicate everything. So for very large objects, it can take a while to collect all the files that you want to download. But again, you have an API, no fancy wrapper yet, it's still a bit rough around the corner, but you have an API to request the download of the object. You can request a notification when the object is ready, and when it is, you go there, you retrieve your object, and you have back your tarball. So to sum up, long-term hosting of completed corresponding source code might be onerous for large corporations. That is what I learned from my lectures and from many other open source people in big companies in the room. And it is okay for copyleft licenses to outsource the responsibility of hosting that tarball to a third-party site, provided you have some agreement and provided you make sure that stuff remains there. Software heritage is meant to keep software available in the very long term. So we are doing crawling. So if what you want to offer is already part of the archive, that's fine. You just find the object in the archive and you can point your user to it. If you have more stuff, which you usually do because you have patched source code, you have additional source code, well, you can now push it to the archive and retrieve it later and point your users to software heritage to find your source code. It's still a prototype. It's still something a bit rough around the edges. For instance, we do not support yet the use cases of doing partial deposit in which you point to stuff that is already in the archive without having to upload again a giant GCC tarball. But that's in the working and something we plan to support in the following. All the tooling is free and open source software, because that's what we do. So if you're interested in being part of this experiment you're doing, you're more than welcome to come and talk to us after the talk. Thanks.
Zach, you may be familiar with something called the Debian Free Software Guidelines.
Rings a bell, yeah.
And part of that is that a Debian developer is going to do a minimal amount of curation of an incoming open source project to determine at a minimum level that the tarball has a proper license, that is an OSI or FSF-approved license. I think it's massively cool, Alexios, that Intel is considering this kind of collaboration. It's fantastic. Is there any potential curation step to ensure that artifacts from, let's say, Intel are indeed open source?
So I'll answer for software heritage in that. So what we want to do is preserve source code which is available, which might be already free software today. It might be not. We want to preserve it anyway because it will become free software one day, for instance, when copyright expires. So, of course, we expect that the use case like there was of Intel, it will be free software all the way through. But the only thing we are doing is adding some automatic detection of metadata, like we run some license scanners, for instance, and we have an API to fetch those metadata. But for now, we don't have human curation of that data. Something that can be added on top of software heritage, but it's not part of the archival part and of this use case. Okay.
The real world,
So in this case, the filtering, the question is, do you worry about people uploading stuff to the archive that we do not want to store? So in this case, the responsibility of checking they do not push crazy stuff or wireless or whatever, it's on their side. But that's why we are only working with selected partner for this kind of stuff. Another example is collaboration with open access archives for papers, for scientific papers. In those cases, we have the researcher adding software to paper, and they can push it to us. But that too is essentially their responsibility.
So will reverse search also be possible? So can I go to your database and say, give me all open source that Intel has used in this product?
So the question is, can we go and search? Thanks. Can we go and search and find all the stuff that has been deposited by Intel? Yes. So the reason why there is an extra metadata and the reason why it is stored as a commit rather than just as a tarball is that so can we have a place where easily add all the metadata, and those metadata will be searchable. Today they are not yet. So if you go to archivesoftwareheritage.org with the credential I've given, you can search, but you can search on only on other stuff like the name of the repositories. But we will open up metadata.
So again, we're talking about the software that, repeat the question, right. So are we not afraid that people will learn what we're using basically, right? Again, think of it, this is the fulfillment service of the thing that we already provide. There is nothing more secret than, whoever gets it could already get it before, right? And we don't. Karsten.
Zach, you mentioned enclosing and passing. You mentioned that it's not as user restricted to just uploading the source code tarballs. You can also just link to stuff that software already has. Is that the same in terms of compliance? The same quality?
So for us, it's just it's to upload essentially incomplete stuff with references to stuff in the software heritage archive. Is that just a convenience step, but I will offer for download the entire thing. Okay? So if you have found something in the software heritage archive, means it's already there, and when I recreate the tarball or the Git repo or whatever, I will do the merge of the things together.
GCC version, and he will he will understand that, hey, I have already that on my archive. We will not be searching to see if he already has in order to upload the patches. For example, right? It's because the duplicate.
I imagine, for instance, next releases of the same product, if you want to avoid re-uploading dependence, you could. That's really up to you. So that's a feature that's available, and then whether you're using it or not, it's up to you.
It comes automatically.
So the question is, full GitHub backup? Yes, we do. And it's scrolling and it's a schedule, so it might be lagging, but that's part of our current coverage. And not only that, if you look at there is a documentation page on GitHub mentioning archival projects, and they point to us as they don't call us as a backup, but we work on archiving that stuff. Of the public part, of course.
Zach, do you see commercial partnerships like this as a way of ensuring the sustainability of software heritage?
The question is, do we see commercial partnership like this as a way of making the project sustainable? So I should thank here Intel. They are a sponsor of the project. And yes, of course, this is part of it. But right now it's more like developing the foundation so that we can offer this kind of opportunities to other partners. Pam? Sorry. Yeah.
So you mentioned that at every point proprietary software will also be available for everybody. What efforts are you making right now to gather proprietary software?
So what I said is that we have no guarantee right now that what we archive is today free software. But the approach we use is that once we go to places that are meant to host free software. So GitHub is meant to host. Of course, people push to GitHub also stuff which is not free today, or maybe binaries. So in addition to that first, let's say, curation step, what we do is that we use automatic tools to detect licenses, okay, and we expose that information. so that the information is available. We do not actively delete stuff, but if someone wants to, discriminate what is free today and what is not, they can rely on those metadata to make the decision.
You're not making any effort to collect this, right? This is really.
Oh, no. No, not at all. Yeah, correct. So someone said it's incidental, yes.
Sorry, yeah.
You guys consider partnering with other archival organizations like
Have we considered partnering with other archival organizations? Yes, and we have. So, for instance, the archive of tutorials that we have retrieved, that's been thanks to collaboration with the Internet Archive. The Google Code thing has been thanks to collaboration with Google. And we are kind of complementary because the Internet Archive stops at the boundaries of source code, basically. So they will not crawl version control systems. They will not open up tarballs and index inside them. And we are not doing the archival of the web part. So in the ideal world, we have persistent identifiers for the stuff they archive, for the stuff we archive, and some external service like Wikipedia or a new Wikipedia of software in the future can make the link between all the things that have been archived. Last question.
speaking of both transparency and another thing, because today or here in Portland, service, the escrow service.
So the question is it correct to say that we are going toward an escrow service? So right now, no, because everything we archive is not like embargoed or anything. But potentially, you can imagine, yes, you can imagine doing that.
Great, let's thank TNT.
Thanks.
Exactly. That is the coolest project. I love it. I'm like, why shouldn't everyone do this? Everyone should do this. This is like the best way of like doing CCS and showing that you've got your plans and you've got like the deposit ticket and the SHA. It's like I love it. I love it.